All right, welcome back. We're going to do the rest of this problem together. We're just diving on in. We've got a object that's been launched vertically upward from the ground, and we're answering some questions about it. So the distance s in meters is given to us as a function of time. And I think we're on question D, the acceleration of the object at any time t. Calculus deals with change, how do things change? And so acceleration deals with how the velocity changes. So the velocity is how the position changes over time. The change in velocity is acceleration. So let's talk about that a little bit more. Oops, that's not question E. Messed up already. Question D asks about acceleration. Okay, so acceleration is just going to be the change in velocity over the change in time. Okay, that's what that's going to equal. So we're just going to write that as a function of time here. Acceleration as a function of time. All right. And the way that we get it is we're just taking the derivative of the velocity. That's all that it is. So our velocity function, v of t, was given to us before. We actually wasn't given to us. We found it. It was negative 9.8t plus 39.2. So negative, what was that? Negative 9.8t plus 39.2. If we find the derivative of that, we will get the acceleration. And the acceleration is negative 9.8. The units would be meters per second squared. Okay, and really my velocity is meters per second. Okay, I'm not going to dive into the physics pieces of that, but that is the acceleration. It's actually the acceleration due to gravity. It doesn't change if you're on Earth. Okay, so that's the acceleration piece. It's really the second derivative of the position one. One other note about that is you might see it written like this, the second derivative of that. So that 2 just means this, it's the second derivative. Or you could see it like this, s double prime of t. It just means take the second derivative. So if you see that double dash mark. If you see a third one, that would be the third derivative. If you see the number 4, that means take the derivative 4 times. So that's a little bit of an aside. Let's dive back up to the next question because I think we're done with acceleration. It says, how long is the object in the air? The object is in the air, okay, so it's got to take a certain amount of time to go all the way up to the top, and it's got to take a certain amount of time to go all the way to the bottom, all right? So what we're going to do is actually we're going to go back to the original equation we've been given, and we're going to figure out when the position is 0, okay? So since this position is given to us, I want to know when the position is 0. So certainly at 0 seconds, the object will be on the ground, and then it'll be on the ground again when it lands. So that would be 0 again for position. So I'm going to take that and set it equal to 0, and then it'll give me the time that it was in the air. All right. So it'll actually give me 2 answers. So A, B, C, D, E. We're going to take s of t. That tells me the distance from the ground. So it's the distance will be 0 at what time is what I'm trying to figure out. So I want to take that original negative 4.9 t squared plus 39.2t. I want to set that equal to 0. And what I want to do is factor out a t. So this is just all algebra at this point. And then I can see that there's 2 factors. One factor is just t, and the other factor is negative 4.9t plus 39.2. And I'm going to take each one and set it equal to 0. This is the 0 product property. So at t equals 0 seconds, we know that we haven't launched the ball yet. The other solution is the one that we really want. And so if we set negative 4.9t plus 39.2 equal to 0, we would subtract 39.2 from both sides and divide by negative 4.9. And you get t equals, let's see, I did this earlier. I believe it's 8, because you end up with negative 39.2 divided by negative 4.9. T equals that. And so t equals, I think it's 8. Yeah, 8 seconds. 8 seconds. So how long is the ball in the air? it's 8 seconds, which, if you think about that, it's kind of interesting. It took 4 seconds for the ball to get to its maximum height, and then it took another 4 seconds to fall all the way down. So it took 4 seconds to go all the way up to the top, and then it took 4 seconds to fall down, for a total of 8 seconds. Pretty interesting there. Maybe that makes some intuitive sense to you there because it is a parabola. It's a quadratic that describes the position. Okay. So that's how long the object's in the air. There's kind of two different ways to solve that. Question F. What is the velocity of the object upon impact with the ground? All right, so velocity. So I have a velocity function over here. Let's see, where's that velocity function? I think that was the first thing I did. Yeah, this velocity function, that should be in meters per second. So I'm just going to plug in the time at 8 seconds because that's when it hits the ground. So negative 9.8 times 8 plus 39.2, and that will give me my velocity at 8 seconds, or when it hits the ground. So which part was I on? That was E, this is F. So the velocity at 8 seconds, because 8 seconds is when it hits the ground, is going to be, I have this written to the side over here, the velocity. So that's going to be negative 9.8 times 8 plus 39.2. And when I do all the math, plug it all in to my calculator, I end up with negative 39.2 meters per second. All right, so that is the velocity of the ball when it hits the ground. The negative represents that it was going down, okay? So that's a velocity is really like a vector, and a vector has magnitude, which is like its length, and the direction. So the direction piece is that negative. And question F also asks about speed. So what's the speed? The speed is like the length of that vector. So the speed is just the absolute value of that is 39.2 meters per second. That's how fast it was going. And when the negative part just tells us that it was going down, it was hitting the ground at that point. All right, cool. Last question. Let's dive on back. What is the total distance traveled by the object? Total distance traveled. Interesting. Okay. Well, we can kind of use some of the hints that were in there. We've already solved some of this because we know the maximum height. So the total distance traveled is going to be just double that. So let's see, where did we have that? This was the question C asked about the total, the maximum height. This was the max height. Max height. And so if we just double that, the distance traveled to get all the way to the top is going to be the same as it goes all the way back down. So if we just double 78.4, we're going to get the total distance traveled. So EFG here, the 78.4 times 2 is 156.8 meters. So that is the total distance traveled. Went through some of those kind of quick. If you have questions, certainly let me know, but I just wanted to give you a little bit of a breakdown on why I'm doing what I'm doing, and I certainly hope that that helps. Thanks.